we're going to be doing water control structures for drainage water management, and Mark Sager is going to be doing our presentation today. So I'm going to turn it over to you, Mark. And you're still muted, Mark.
Oh, Tim, can you confirm you can see the presentation?
I can see your screen and hear you.
Okay, fantastic. All right, gang. So today we're going to talk about controlled drainage structures. I'm going to specifically talk about them in regards to the H2O Ohio requirements. And if you have any other questions, I mean, it should meet all requirements, whether they're signed up through NRCS or through ODA. So again, we can answer those at the end, but you can always type a question and Tim will try to get those to me. We'll go ahead and get started here. There are several different types of structures out there. The first picture on the left is one from ADS. It's a square box with stop logs in it. The next one is a structure. It also has stop logs in it. And then they've had several other ones out there, but I would say the majority of them are the ones on the left that we've been putting in. They seem to work pretty well.
Mark, you're back on mute for some reason. Mark, you're still on mute.
Can you hear me now?
Yep.
Well, that's interesting. When I hit this advance, it puts me on mute. Okay, I'm going to go without the slide. We'll just click on each sheet here. Tell me if that doesn't work. Going back to this plan set, Dwayne Reithman, state engineer, sent this CAD drawing out. It should be a one-page plan that we could use for a controlled drainage site. It's got the OOPS information, the materials information, a site location map, and then two different scenarios of putting the structures in. One at the edge of a outlet or at the ditch bank or stream, and the second one maybe at the edge of a field location. So if you don't have that and you would like it, let us know and we'll get that sent over to you. One of the key points in this is that it's very helpful to get a survey of the outlet elevation and the ground elevation at the structure location. Of influence for these structures, but it also helps us to get the right size structure, the height of the structure. Or so usually want those structures to be sticking out of the ground at least a foot or two, just so that they're seen and they're easy access. Tim, can you hear me?
You're breaking out a little bit, but I can hear you now.
You can hear me. Can you still see my screen?
It still says survey.
Okay, that's good. Sorry about this, gang. It's my network is not as good today. So in H2 Ohio, one of the criteria is that we have a 10-acre area of influence for 10 acres of influence for a structure at 2.5 foot elevation change from the structure. If we're going to do a structure with a main, we're looking at 20 acres for a single structure. And so how do we get to that point? Well, we can utilize LiDAR or a topographic map or something along those lines to calculate that area of influence. We can insert this map into the plan, or we can keep it in the design folder, but it's something that we need to have somewhere where we show how many acres that we're affecting for H2 Ohio. And I know in some of NRCS's programs too, it calculates into their maintenance of how many acres they're maintaining. So let me show you a couple examples of a site. You could use this LiDAR map here. You could pick out where the structure is, and then you could draw in using the contour lines that area and calculate it and figure out how many acres that you might have. You could do it in our or Google, Earth or something along those lines, that's showing the area of influence. Good thing that you could put either on the plan or again put in your design folder. Here is that same site put into the site map, and it shows that area of influence for that structure that we're going to be installing. So it really makes it a nice clean area. It's not required, but it is nice.
Hey, Mark.
Yeah.
We had a question about, can you give a brief overview on what the purpose of these structures are for and why we're installing them?
Okay. So if you can hold on to that question, I'm going to talk about what these structures do later on, or what their results are. And hopefully that'll answer it. If it doesn't, we'll come back to it. Okay.
Sounds good.
Okay. Tile maps. These structures, we want to put them in on systematically drained fields. A lot of times you can tell that the field is systematically drained by looking at aerial photos. Sometimes the landowner will have tile maps such as this. It could be hand drawn. I've seen them where they've been GPSed in now, and you can get a nice digital format. Again, the more information that producer is able to give to you, the easier it is going to be for you to figure out that area. It'd be a good thing that you can put into the folder. It doesn't necessarily have to go on the plan itself, but it is a good piece of information to have. Another thing these tile maps do is it leads us into our next point. We need to be aware of where these systems are being, or what they are draining, what area of the field, because we could have a tile main that's running over to a neighbor. It could be draining the neighbor's house or field, and you'd be like, well, what's concerned there? Well, septic systems or basement drains could be connected to that system. We may also impact field drainage if it's flat enough, even if it isn't flat enough, and it's just a perception that the neighbor is seeing you block their drainage system. So if we are going to have a main that's running into a neighbor we're going to have the structure on, we need to make sure we have written permission from that neighbor before we put that control structure in on that main or sub main. So what is items in a controlled drainage structure? Usually we're looking again for a systematic drainage system. So generally they're 4-inch tile installed on 40 to 60 foot centers. We look for a tile main collecting the systematic system or a sub main. We're going to have a control structure, and then we're going to, on that sub main or main, we're going to put a 20 feet of pipe, our structure, another 20 feet of pipe, and then we're going to put either an anti-seep color or bentonite on that outlet side of the structure. I got some pictures here of doing that. So here's a site where we're putting in on the maybe on the edge of a field. It's not on the outlet, but you see we've dug up the main and put in 20 feet upstream of the structure, and then we'll put in 20 feet downstream of the structure. Here's a little better visual picture of that structure with the stop logs looking down into it. You'll notice whenever you're putting in these structures, they'll have to dig out. I've seen this a number of times. You have to dig out the bottom of the structure a couple inches, 1.5 inches, 2 inches, to have it set level so the pipe comes into the fernco here to make a good connection. So that's one of the pieces you need to watch during installation, is that they actually get that level or dug out and leveled so your pipe comes in there on grade. Here they're setting that structure, making sure it's level, got their outlet pipe connected. And on this structure here, we put an ANI seep collar in downstream of the structure. This one's not perfect. I wish I had better pictures. You really want these anti-seep collars to be into the side of the bank a little bit, just to help with that seepage path to go around. So you really have a good seal around that pipe. Here it is being backfilled around it. You want to backfill on both sides of it. When you're backfilling around the structure itself, you need to make sure that they're not using mechanical means to compact around it, that they're hand compacting. Because with these boxes, if you put too much compaction on one side, you could kind of warp these boxes. So you have to be careful on the backfill of these things that you don't distort these structures themselves. Here's a structure with bentonite going in instead of that anti-seep collar. Again, what easiest way to do is put some dirt on the downstream side, the upstream side, and then pour the bentonite seal. And basically what this stuff does is it's a clay. When it gets wet, it swells and creates a good seal around it. Again, I like to see this go underneath the pipe to the edges of it, into the bank a little bit, and then up above the pipe. I even on the plans itself, it says a good foot above the pipe. This isn't quite there, but we really want to just create a good seal around to limit the flow path for water, because once we put these stop logs in there, we're going to have water build up behind them, and it's going to try to find ways around the structure until we get this material to really settle in around all the pipes. Here's again another picture of them putting bentonite in there. This is a pretty good one. Again, I would have put maybe dirt here and here just to save on some of the bentonite and allow it to build up before I put the material in there. How to manage these. So during the non-growing season, basically after fall field operations till April 1st, those boards to within a foot of the surface, okay? April 1st, we're going to pull the boards, allow the field to drain, and allow them to do their normal field operations. In the summertime, if they want to, after side dressing corn about that time, they could install the boards to within a foot and a half of the surface, and they could watch it and manage it for keeping water into the field system or the operation. Again, this is going to be optional for the producer to manage. We don't want to be telling them when they have to close it during crop season, but it is something where they could save or conserve water during the growing season. So this will get to that question, why are we doing these structures and where? Well, if we use drainage water management and we put these in the non-growing season, we can reduce the total liquid discharge, or the total volume of water leaving that field, by about 50%. Now we don't change the nitrate concentration leaving the field. We just control the amount of volume. So therefore, the total nitrate load discharge from the drain will also be reduced by about 40 to 50% in that non-growing season. So that's one of the main reasons for installing these structures. And if we're putting them in on a field, we really don't need those fields to be in a free drainage mode in the wintertime. There's no real reason to have those in a free flow drainage mode unless they're attached to a house or a septic system or some other reason that you do need that drainage. What kind of loads? Again, we got this out of a report a while back, and these numbers I'm sure will move, and we're getting better numbers. But nitrate, how much moves through a subsurface drainage system? Well, nitrates, it could be 50 to 40 pounds an acre annually. Again, most of that nitrate load occurs in late winter to early spring. Soluble phosphorus might be 0.04 pounds per acre annually. Potassium, maybe 2.3 pounds per acre annually. So you see, we do get a nutrient load out there, and if we can, the one that we know that we can affect is the nitrates. The other two, not so much, but it is a way to affect the nitrate load that we're seeing. And for the algae blooms, you have to have both nitrogen and phosphorus to make it occur. So if you can at least start reducing one of the nutrients, then you should be helping that system. I'm going to go to some example sites, or one example site, and you're going to see if we're eligible here. So I have two structures here with a topo map and the tile lines drawn out on it. And the question is, how much of the area influence would both of these structures have on it? So if I go to the first such site here, I have basically 9 acres and that 0 to 2.5 foot elevation change. This structure by itself, according to the H2O Ohio requirements, is not eligible. We need to have a minimum of 10 acres of influence. But if I add in my other one, in this structure itself, it has basically 20.2 acres of influence from that structure, just from that one. So if I add those two together, I'm looking at almost 30 acres for that same field with two structures. So the one to the top of the site or page here would not be eligible by itself, but in combination in this field, if they're on the same plan set, they would be eligible because we're controlling almost 30 acres with these two structures, meeting the requirement of 10 acres per structure in this. So
Hey,
hopefully
Mark,
that makes sense. Yep.
we got some people saying they can't see your screen. If there's a large number of people that can't see it, can you let me know or put a message in the chat? I can still see your screen, Mark, but we're getting some messages that other people can't. Looks like most people can still see it, so carry on.
Okay.
All right.
Sounds good.
Your
Okay,
screen is a
so
little
hopefully that
slow to
makes sense.
refresh, Sorry, I was saying your screen is a little slow to refresh when you change slides. So when you change
Okay.
slides, maybe slow down a second so it can catch up.
Nope, can do. All right, so I'm going to go back up to the first slide of this screen. So again, this is that site, the field. I have the topo lines under it with the layout of the systematic drainage system. I have two locations for structures, and with the topo lines, I can calculate the area that each structure would have. So I'm going to go to the next slide and wait a little bit. So the structure that I'm showing right now to the top of the page, it would only have about 9 acres of influence from that location. So in this situation, by itself, this site would not be eligible for H2 Ohio requirements because we need to have a minimum 10 acres of influence. But when I look at the second site, I have about 20.2 acres being controlled by the second structure. So when I add both structures together, I'm controlling almost 30 acres of this field in that 2.5 foot acres or 2.5 foot zone of influence. So under H2 Ohio, we would say that both of these structures would be eligible. But individually, the one to the north would not, but combined, and we put them on the same plan set, mark them in a beehive as 30 acres of influence under one structure or one site, we would meet the requirements. So hopefully that makes some sense. Where's the best locations for these structures? You really want the large. You're really looking for 0.5% grade or flatter. You're really looking for a properly sized and uniform drainage system. And we're looking to put one structure per outlet if possible. What things do we need to worry about? Sandy or silty soils will, and I put in this because manure, because I know some of these put these in for liquid manure application. But even for controlling water in the field itself, if we have really sandy or silty soils, these structures may not do a whole lot. It may just allow the water to bypass the structure or for to continue on past the system. We're putting these in clay soils. We just need to make sure we have good compaction and that we're not damaging the structure when we're putting these in. We have to maintain these structures. The seals or the gaskets on these boards, you need to make sure they're lubricated and maintained. If they dry out, they could tear off of there. If you look at too steep of a grade coming up to a structure, and they're putting liquid manure on behind this system, we could cause that liquid manure to come up to the surface behind that structure. So it's some things you have to be aware of when we're putting these systems in and you're using it for liquid manure application. So I guess I want to go back and make sure that the question as to where you put these in and why was answered. And if not, please let me know and I will try to answer it better.
I think you got it, Mark.
Okay. Are there any other questions out there? You could type it in or feel free to unmute and ask me the question.
Hi, I do have a question. Can you hear me?
Yep, I can hear you. What you got?
Okay. I apologize if this is a silly question, but I am new to the area. So these sort of control structures I've used before to regulate the level of water in ponds and such like that, Now,
That's correct.
If I'm understanding you correctly, this is to slow down the discharge of nitrogen to, Lake Erie and other large bodies of water. But the subsurface drains are to move water quickly from the field to avoid overland flow. So by reducing the flow of the subsurface drains, wouldn't you run the risk of ponding on that field and producing overland flow?
No, well, two reasons no. We leave a foot of free drainage on top for it to soak in. And just because you raise the boards up does not mean that water level stays level in the field. It'll eventually move down below the tile drainage system. It's always just like the tile drainage system wasn't there. Eventually that water is going to move down through the soil profile. So therefore, even though it may rain and the water level comes up the next day, it's not going to stay there but more than a few days unless it rains again, if that makes sense.
Right, okay. So by leaving that foot, you allow the water to continue down through the profile.
That's right, and it doesn't stay a foot below the surface. It'll come up during a rain event, but then it'll eventually drop down. And even during the wintertime, you could see it drop clear down to the bottom of the tile system again.
Okay, awesome, thank you.
Yep.
Mark, we had another question in the chat asking to describe the area of influence a little bit more. Is it the same as the drainage area?
So we make it easy in the sense that all we ask you to do is look at the contours themselves. Theoretically, they could have not drained it completely to that structure with their tile system. They could have broken, let's say, for a better term, some grade putting a tile system in, depending on where they ran their submains. So we just ask you to look at the contours themselves to figure out that area of influence.
We don't have any more questions in the chat. Anybody else have anything they want to ask Mark before we wrap up? I think that might be it, Mark.
Okay. Thank you for joining us. And if you do have any questions on these, feel free to give myself, Mark Sager, or Tim Folks, or Justin McBride a call, and we'll gladly help you out with these. So thank you for your time.
Thanks, everybody.